I'm putting the door cards into working form, and I just finished re-sealing the backs of them because I'd sanded them to get rid of the waterproofing so that I could soak them and get them wet and bend them back and dry them in the flat, and they're flat now. I'm using this Eastwood product, and it's kind of like a yellowy wax. It is removable with a mineral spirits. It dries, and it's, it doesn't stick. It's not sticky when it dries, but for me it's just like seal it all up, and then I can put new foam in the grill areas and then reinforce those grill areas, and then flip them over and start coloring and putting new elastic in and various things to make these door cards ready for final assembly. So I've put the foam, cut the foam and layered it in, and then put some a thin perforated metal baffle on it, and then I've just attached the baffle using the same high temperature wax anti-rust formula that I reapplied to the back. Now, Volkswagen had used various types of anti-rust, and they did use wax in a few areas, and this is an area that I've just reapplied the wax, and nothing will stick to wax obviously other than wax, so I've used the wax to build up the wax to get it to stick to the grill. So we'll see how effective that strategy is here. So this is the Rockford Fosgate low profile subwoofer, and it's going to go under the package tray here. Let's see if I can do this with one hand. The woofer's pretty heavy. Yeah, so I'll zoom back out. So it's going to get tucked into there in a box, and it'll be flush. The box is going to be flush with this edge here running up and then going back, and so it'll be using this woofer doesn't take a big volume, and I'll vent the port out through where the original speaker was, so and have some insulation in the back in this area. So I'll build a nice box and probably have it in the same blue carpet actually. And I've got a I'll show you the rest of the stuff in a sec, but I have the cover for it, and I'll show you the back of this in a sec as well. Oh, by the way, so yeah, I'm going to build in here an aluminum box to hold my lithium power cell, my 20 amp hour lithium pack, which will be awesome. I've just been using the old lead acid technology for now, and yeah, I'm going to ground the battery here, drill a hole and mount a lug here, and then get rid of this ground return line. So I'll ground the battery to the chassis here, just run the positive to the front. I will then ground the engine and the front electronics at the front as well with another lug, and we'll see how that goes. And I have to build a current, well, I've already got the basic electronics, but I'm building a current sense circuit that's going to allow me to see both positive, like charging, and as well as draw current to the engine ECU, so I can see on the dashboard, I can see whether I'm charging or whether I'm discharging and how much I am. So basically the way I'm doing that is I have a 2.5 volt reference, and I have a current shunt. This is my current shunt here, a very low, like 200 amp shunt that's, 0.0 ohms or something, 0.01 or something ohms, and it's a very small voltage drop across it, which is detected by a differential operational amplifier. And so if the current flows one way, you get a positive voltage across the shunt. Flows the other way, you get a negative voltage across the shunt. So got a little circuit that's coming together that'll do that and feed that into a 0 to 5 volt analog input on the ECU. Yeah, so I'm fiddling around with that. Here's a whole bunch of electronic goodies. So there's the back side of the Rockford sub. It's a got rare earth magnet, so it's not heavy. It's less than 5 pounds, and it's got 500 watt continuous power handling capability, and that's the grill I'm using with it. And so tons of power, but very controllable. It's driven off of the kicker amp, so it's kind of rated at five channels, total of 250 watts per channel, but it works out to be a little bit less than that. I mean, it's 1200 watts RMS total, but bottom line, it's going to be, I'm driving the Hertz speakers, which again have got rare earth magnets, so they're not heavy. So the tweeter's going to take no power at all, you know, maybe 1 or 2 watts to drive, but I'll be dedicating like a 125 watt RMS channel for it. Same thing with each woofer. So the tweeter goes along for the ride, the woofer works hard. This is the IQ interface. So that little box that sits on top of the kicker amp is the Bluetooth interface, and lets you, with a kicker app on your iPhone or your Android phone or your tablet, allows you to do all the EQ adjusting and software and crossover points and time delays, and all the software is configurable over wireless Bluetooth. You can also plug in a USB and do it on a PC or a Mac. And then over here is the Boyo backup camera, and this is the little actually, sorry, that's the display. So it's in the form of the rearview mirror, and you end up with this type of situation where you back up. You end up with the screen, wide screen on one side where it appears, and it's auto dimming at night, and then you've got your compass and your temperature. So there's an external temperature probe that wires in, and then this little guy hangs, you know, where the lights are for the license plate. Just hangs down, very professional looking OEM little unit, very unobtrusive. So that's what's going on there. And then I think I've showed you this before. This is my Concorde HPL 130. Vintage from 1983 with DVX noise reduction. This was state-of-the-art in the day. CD level of performance, yeah, with tape technology, both in frequency response and signal-to-noise ratio. So that's going to be my head-end unit, which will wire into the Kicker IQ, plus I'll have streaming audio available, and cellular phone, hands-free, and everything through that Kicker IQ interface. So that's my electronic stuff that is going into the vehicle, and it's a lot of fun getting to this point in the project, that's for sure. I love this stuff. I got these fittings figured out for the air conditioning unit, air compressor and all that stuff. So the compressor we're going to attach by soldering copper 3/16 and 1/4 inch copper lines, and then use compression fittings. So this is an example of a compression fitting. So I can tap into the high side line and then come off that to another compression fitting that then goes to the standard ports for injecting and servicing the line. So I've got the gauges and stuff. So the high side, low side gauges connect to the high side port and the low side ports. So these ports are good to go. So basically it works out that I go from compression to MPT fitting, from MPT fitting to 1/4 inch 45 degree flare, what they call an SAE flare, and then onto the DIN, the European, I think it's 14 or 13 and 16 millimeter access ports, which are O-ring quick connect ports. And this is the expansion valve, Danfoss expansion valve. What this does is basically this temperature bulb sits on the output side of the evaporator, and if the temperature starts rising, it opens the valve up more. Temperature gets low, it closes the valve off. So this, in combination with my computer, the ECU, is going to monitor the temperatures of the evaporator and the compressor, and then it's going to speed up and slow down the compressor. And then this will, on a mechanical thermodynamic basis also assist by opening and closing the valve and letting more refrigerant through as is necessary. And then I have my receiver dryer as well. So I've got to make, I've got some more fittings that I've got to actually make up. The this is not the right size, but basically the receiver dryers use these O-ring fittings, and except in the number 6 or dash 4 or dash 6 size. And so what I'm going to be doing is soldering aluminum to copper using a special solder. I'm going to solder on the copper tubing, and then I'll be able to attach. So a bunch of fiddling to get the right connectors for everything, and I'll document all this so that if someone wants to duplicate it, it's not going to be so painful for them. I've got some really good news. I was trying to take a set of these side vents and adapt them to the center outlets, because I just couldn't get my fingers on an original air conditioning combined vent that bolts into the same place with that sort of open glove box areas in the center. And I found on eBay this week and purchased what looks like a mint unit. So I don't need to do this. These things, first of all, are slightly too wide, and they just don't, I was trying to jury rig connections to the defrost, the windscreen connector with some tubing, and I'm so glad I didn't cut anything, because in frustration I was Googling around looking for another set of these vents just in case I buggered the ones up I was about to cut, and lo and behold, that rare auction appeared and I grabbed them. So I might get them as early as Friday, but it might be early next week before I get them on hand, and then I'll get that installed. So I gotta get the dash in. I cannot get the dash in until I've got this air conditioning vent thing sorted, so it's sort of a gating function. I'm making some wiring changes. The 12 volt solenoid, the 150 amp solenoid, I am replacing that with a solid state unit. It's not going to be here until next week, it looks like. So in the meantime, I've torn out the ground return to the remote battery, and I've permanently put in both the 1/0 cable as well as a number 4 cable. The number 4 cable is for things like the ECU and the fans and the water pump that want permanent power even when the ignition's off, and you want to connect those directly to the battery. So I got a separate cable for those, because when you've got the starter motor kicking in, you don't want the ECU to be having the voltage drop. So you'll see up above there's my battery connection. So my 1/0 cable there from the panel goes to the frame, and I've got some dielectric grease on the contacts as well. So I'll show you the back in a sec. So here we have my lithium battery, and that's also the power amp that's going to be going down here. The only thing that's missing is my this is the current shunt, so this is a very low resistance connector on the negative side. The negative runs to this post here that's been put in, and yeah, got a really solid connection through the frame to the front. So I know you're not supposed to do that, but I did, and it's very solid, and I'll maintain the quality of that connection. And I've also got ground wires running to the starter motor, ground wires running to the block of the engine and stuff. So I'm taking good care of the grounding. So I will be putting a new measuring device across. I have a temporary one that I've got ready to the front to monitor, but I'm building my own current monitor that connects to the ECU, that both charge as well as discharge. And then this is the one of those wireless battery disconnect switches. This one sucks. This is Worthco, and this is the remote control, and it doesn't fucking work. It worked for an hour, and then it packed it in like a lot of junk, made in China stuff. So anyway, not to be disparaging against the Chinese, because they make great stuff like Apple iPhones too. So it just happens to be that this is not super high quality. So I'm getting a replacement unit for this, but I'm also buying a different unit from another manufacturer. Nobody's got super high ratings. Everyone's got complaints on the internet saying, oh, the thing stopped working after X period of time. So I think the concept is great. You got a little wireless, you know, it's very low power. It'll automatically disconnect your battery if the battery gets low, and then you can reconnect it and still start the car. So it's got all kinds of great features to save your battery, and you know, it's a security feature to be able to remotely kill all the power in the car. So I will experiment with other manufacturers and get a replacement for this unit as well, and lo and behold, it'll all work. So I'm just going to fire this car up with the lithium-ion battery for the very first time, see how the thing cranks over. So the first thing I'm doing here is I'm just checking to see how much voltage drop across that current shunt is in the trunk. So I'll kick it over and we'll see with charging current what the voltage drop is. Oh, hang on, I'm going to turn the ignition on. Okay, there we go. 1, 2, 3. So it's 0.05 volts, so nothing to complain about. Now let's look at the battery voltage while we're cranking over. Nice. So it's only dropping to 12 point something volts. Fantastic. And one last test. This is going to be the voltage across the electrical remote battery cutoff. So again, it's about 0.05 volts. So between that and the shunt cranking, I'm losing 0.1 volts. And it's awesome. And the cranking sounds fantastic. Now time to start the motor and I'll show you something else. Well, this is what I wanted to show you. I've got my new air intake box with the thermally molded Lexan. So this is now replacing the old unit that I'd made, which is down there. It was sort of a bit of a prototype, glued together with individual sheets, but I didn't have the ability to curve it because it takes about 400 degrees Fahrenheit to curve Lexan. So I got a shop to make some curved pieces for me, and then I finished machining it all and getting it put together. And yeah, it's going to be awesome. There's no question it's going to work nicely. Sort of have a look to see how they're lined up in there. Let me just go to the discussion about whether this is going to restrict airflow. Well, first of all, putting filters on the trumpets generally kills power, but as soon as you're, according to Gen V and a few other guys, if you're more than 1.5 inches away from the front and you've got some clearance on the sides and top and bottom, then you should have no restrictions. And I've got a massive air filter and a massive 4-inch intake system, and this should be good for 1,000 horsepower plus engines. And I don't think there's going to be any significant restriction at all. And it's certainly going to keep it quiet, but we'll see. It may actually make some power because you don't have turbulent air coming in. So, you're seeing the throttle bodies through the gap here in the front of the grille. You'd end up with a lot of air going straight in maybe, but it could be turbulent. So we'll find out. We'll go to the track and we'll run some quarter-mile timing, and we'll do some horsepower, wheel acceleration horsepower tests, and with and without this intake, and we'll see whether it restricts it. But you don't want to run a street car without filters because you'll suck in dirt into your system and wreck your motor. So anyway, I'll fire it up and you can listen to it'll sound different because you won't have that ITB sound, at least not nearly as loud. So I'll fire it up and we'll try it. Okay, we'll give it a whirl. Here we are. 1, 2, 3, go. Sure starts nice when it's cold. So let's go over here and listen to it. So you don't hear the ITB sound anymore. That may be sad, but it's a reality that that can be a bit annoying on the street. So there you go. You can hear a little bit here, the intake to the air filter, but otherwise it really does quiet the engine down a lot. It's nice. Loving it. Love the way this engine starts so cleanly now too. Starting to get it dialed in pretty awesome. So anyway, that's it for now. So just one comment, it's way quieter. So revving it, it's quieter too. So yeah, it's going to make for a much smoother, quieter sounding car.